So what I'm going to show you guys today is how to use a diagram, not just to make sense of all this wiring here, but how to use the diagram to find certain test points on a unit, how the diagram tells you what kind of voltages you should expect to read there with the multimeter. So we're going to go through a diagram step by step using our multimeter to find all these test points so that we can develop a skill set that you're going to be relying upon whether you're brand new or been doing this for 20 years. And one of the first things you want to do is find the diagram itself, which is usually on the inside of the unit. So we're using a Goodman furnace today as an example, and our diagram was right on the inside door. So I'm going to go ahead, I'm going to put this up on the screen so you guys can read it better as I go through it. Now we have two different diagrams here. We have our full diagram on the left and our ladder diagram on the right. These are both showing you the exact same thing. They're just showing you in slightly different ways. And as we go through the video, I'm going to show you how each one can come into play and help you figure things out. So the first thing I like to do whenever I'm looking at a schematic is I always look for the power source coming in. So on our full schematic, we can see junction box, and that is actually our switch right here on the side of the unit. When we look at our diagram, we see disconnect and then junction box. That disconnect is basically the breaker back at the main panel, the electrical panel. So the junction box on our ladder diagram is the same thing. It is our switch here. So going back to our full diagram, we see we have a black wire and a white wire coming off of this switch. And when we look at the wiring coming into unit, that's exactly what we find right here. Our black are 120 volts and our white is our neutral. Now going back to our diagram, we could see that black wire brings us right to a blower compartment door switch. So that's our door switch right here. So when we follow this black wire right here, we could see it brings us right to our door switch right here. So as long as this switch is on, which it is right now, I should have 115, 120 coming up to this switch right here. Now you're not always going to read exactly 115 or 120 as it's stated on the diagram. You're going to have a little bit of variable there. So let's take our multimeter, we'll put it on VAC. So I'm going to take my probe, I'm going to put it on the door switch terminal there. And I would take the other one, put it on ground, and you can see I'm reading 125. So I know I'm good all the way up to this door switch. My breaker is not tripped, my power is on, and I'm good up to this point. Now this door switch is going to break that circuit because I have the door off. So if I were to test the other side of that switch to ground, you could see I'm reading nothing. But as soon as I push that door switch in, the switch is now allowing the 125 volts through, and it is carrying on to the rest of the unit. So just by looking at this schematic and learning how to read it and trace the power in, I've just figured out how to diagnose a door switch. So if I have 115 coming in but not coming out when this switch is pushed closed, I have a bad door switch. So coming back to our schematic, we can trace that black wire coming out of our door switch and see where it goes from there. Now on the schematic, we follow it and we can see it goes down to line H block, and that is on our integrated control module. So this whole square here is our control board. So if we take this black wire, this is the black wire coming from our switch into the door switch. We have our other black wire coming off that door switch and going down to our control module on the line H terminal. So you can see on our close-up here, we have our line H terminal with that black wire coming in. So if I were to go ahead and put my probe on there, go to ground, I'm not reading anything right there. And the reason why I'm not reading anything right there right now is because my door switch is actually open. So what a lot of guys will do is they'll take a magnet like this one, they'll stick it right on that door switch so that it stays closed. And now we can go back and test for power on our line H terminal on our control module. So I'll go ahead, put my probe on there, go to ground, and you can hear my multimeter beeping, which tells me I have 125 volts there. So now I know my control module is actually getting power. Now you can see right above those terminals, we have transformer H and circ H. What that is, the transformer, that is our 120 to 24 volt transformer. and the circ H is actually for the circulation blower right there. So when we go to the ladder diagram, there's something I want you to take notice of. Some of these circuits off of this line voltage have switches in them and some don't. So basically what that's telling you is that if it has a switch in there, you're not going to read 120 volts off that terminal right now. Whereas if it doesn't have a switch there, you should read 120 volts on those terminal blocks because they're connected to the line voltage without any interruption in between. So for example, circ H on this ladder diagram has no switch in it. So what that basically means, if I were to take my probes and test for power right now on the circ H terminal, I should read about 124 volts there. So I'll take my probe, I will put it on circ H, I will go to a ground, and you can hear my multimeter going off, and I have 125 volts there. Now the same thing is true for the transformer. You see there is no switch on this diagram, so it is wired directly off a line to the transformer. So if I were to take my meter, put it on that transformer terminal, go to ground, once again I'm reading 125. So what we're figuring out here is where we always have live power no matter what state the unit is in. Even when it's in idle, sitting by, it's not cooling, it's not heating, we always have power on those terminals because we now can look at the schematic and see where we should have power at all times. So now we know two things. We have power coming in on our line H, we have power going to our transformer, and we have power going to our blower motor. So going back to our full schematic, we could see we have a black wire coming off a transformer H terminal on our control board, which we just tested. We have 124 volts coming off of that. So that is our black wire right here. We should have 124 volts coming off of transformer H into the primary side of our transformer. Now on some of these transformers you can test for the 120 right there. This one I can't, it goes inside the transformer. So what I do in these situations is I just test the low voltage coming out the other side of the transformer, because that is the whole purpose of the transformer, is to take that 120, step it down to 24. So you could see on our schematic we have a red and a blue wire coming off that transformer. It'll be the red wire. I will put my probe on R. I will go to ground or the chassis of the furnace, and you can see I'm reading 29 volts on my multimeter. So that is telling me the transformer is in good shape, it's doing what it's supposed to do. Now if I was not reading 24 or 29 volts off of the secondary side here, that could indicate I have a bad transformer, because even though I have 124 volts on that transformer terminal coming off the control module and going into my transformer, I'm not getting the voltage coming out, and that's a bad transformer. So going back to our full schematic again, we see that red wire coming off our transformer, and it goes down into our Molex plug here. Now some units it might go into a Molex plug, on other units that wire will go directly into a terminal on a control board, but either way, this is our red wire here going back to the control board, and this is a pretty standard setup. You're going to see power coming into the control board, 120 volts. That power is going to go into the transformer at 120. It's going to come out at 24 and go back to our control board. So regardless of how it's wired, you're usually going to see that in all furnaces. Now the next step here, if we were doing diagnostics, is to make sure the 24 volts is actually making it to the control board. Now when you take this Molex plug off, you can test from the other end, but you do not want to use your normal terminals on your multimeter, because this wide terminal will actually slightly damage the Molex plug connector, and you will not get a good connection, and that can cause all kinds of problems and the unit won't run properly. What you need are adapters that go on here that are very, very thin and fit in there, and that you won't have that problem. But there's another way to do this, just from experience I'll show you guys. Whenever you have 24 volts coming off a transformer and going back to your control board, the first place it will always go is to the fuse. So we could see our little 3 amp fuse right down in here. Now Now some schematics might show this, some will not. The schematic we're working with today doesn't actually show that, but with all furnaces, that 24 volts coming off the transformer back into your control module, the first place it's going to go is to that fuse. So in order for me to test to make sure that red wire and the 24 volts is going into the control board just fine, instead of pulling that Molex plug off and sticking my probes in the Molex plug, what I can just do is go right to the fuse and test for power there, because that's the first place it's going to go anyway. So I will put one probe on the fuse there. I will go to ground, and you can see I'm reading 29 volts. So what that's telling me is my 24 volts coming off my transformer, it's going into the Molex plug, it's feeding back into the control board, and it's making it to the fuse. So I'm good up to that point. If I was not reading 24 volts on this fuse, but I'm reading it coming out of the transformer, I could have a bad Molex plug connection here. Once the power makes it to the fuse, it's got to go through the fuse to carry on. So to make sure we actually have a good fuse, we now want to test the other side of that fuse, all right, and see what we got there. And we are reading 29 volts. So we know we got a good fuse. If I was reading voltage on one side, but not on the other, you could have a blown fuse, and you just take that out, hold it up to the light, and see if it's blown. Now, schematics are not going to show you the internal wiring on the control board itself, but what I just told you is pretty standard for most furnaces. You're going to have the power coming off the transformer, going back into the control board, and directly to the fuse itself. Now, the power coming into the control board is just going to the fuse. It's not going anywhere else, and the whole purpose of the fuse is to protect the control board itself from shorts in a low voltage circuit. Now, if we back up a little bit, we take a quick look at this diagram again, you'll notice that there's thick black lines and thin black lines. The thick black lines were high voltage, and that's what we were testing through most of this video so far. But once we got on the secondary side of the transformer, you notice the lines on the diagram, they got thin, and from that point on, we were testing low voltage, so we were getting 29 volts on those wires. Now here's another thing a lot of schematics may or may not show you, and that is once the 24 volts leaves the fuse, it's going to ultimately end up on the R terminal, on our terminal blocks that ultimately goes up to our thermostat. But between the fuse and the R terminal, it is usually going to go through a safety of some kind. Now, different brands and different models might go through different types of safeties, but there's always going to be some kind of safety that 24 volts gets to before it goes to that R terminal. And once again, sometimes a schematic may not show you this. We don't see it on the schematic we're looking at today, but you can pretty much guarantee every furnace is going to work that way. Most furnaces that I've worked on, those safeties are going to be either one of two, sometimes both, but it's going to be either a flame rollout switch or it's going to be our thermal high limit switch, which is a probe that goes into the heat exchanger to monitor the temperatures inside. So both of these are temperature switches. The flame rollout is basically what it sounds like. If the flame starts rolling out of the furnace, it will open this switch, kill the 24 volts that's coming from the fuse going to the R terminal on our terminal block on our control board. So just to show you what I mean, if I were to test for 24 volts right now on this flame rollout, you can see I'm reading 29 volts there. So on this particular furnace, that 24 volts goes through the flame rollouts before it makes it to the R terminal. Now on other units, you might have something different. It might go through that main high limit switch there rather than the flame rollouts. But either way, you can usually test one of those switches to see if you have any power there, and that will tell you that that's worked into the circuit prior to that R terminal. So if you do ever test the R terminal on your control board and you're not seeing power there, but you have power at your fuse, one of these limits are most likely triggered. So if I go ahead and I test for 24 volts at this R terminal here, I should read voltage if everything is okay. And I am reading 29 volts there. Now watch what happens when I unplug one of these. I I took that wire off of the flame rollout there. Now you can hear my blower turned on. That's a safety feature. But if I go ahead and I test again for 24 volts at that R terminal, I am not reading anything. I read 0 volts. Put that back on, turn our power back on again, and when I go back to that R terminal, I am once again reading 29 volts. So, like I said, this is not something you always see in schematics. A lot of guys don't teach you this. Sometimes it's just something you got to figure out on your own sooner or later. But you can rest assured, if you're ever getting this far into a diagnostic procedure and you're not reading 29 volts or whatever the voltage is on that R terminal, and you do have it on your fuse, you want to start checking the safeties in your heating circuit. Now keep in mind, this is how the furnace is wired. So even in cooling season, air conditioning is hooked up to this as well. So even when your air conditioner is running, these safeties still apply. The heating safeties are still in the circuit and they're still playing their roles. So say, for example, your air conditioning system is running, your blower motor is overheating, it's starting a fire, that thermal limit there might pick that up and shut the whole thing down. So it doesn't actually have to be in heating mode for these heating safeties to play a part in the operation of the system. So that's basically what makes all this wiring complicated. It's not so much the functions that need to happen for the unit to run and work, it's all the safeties that are worked into it. On top of that, you have optional features, humidifiers, UV lights, all makeup air, all kinds of other things that are worked into these circuits as well. So basically what it comes down to is safety and sales, and then you have advances in technology. So instead of a regular split capacitor motor with just like 2 or 3 wires coming to it, you have like ECM motor that has several more wires. So it does pile up, and using schematics really helps you work through it once you know how to read them. So going back to our R terminal here, this is the wire that goes up to the R terminal in our thermostat. And this is essentially the beginning of our low voltage control circuit that is not going to be in our wiring diagram, because the wiring diagram only covers the wiring inside the unit itself. It doesn't cover what's called field wiring. So your thermostat wires here going up to your thermostat is basically field wiring. And that's something you just have to know. I do have videos on this. I will leave a link in the upper corner of the video. If you want to go ahead and watch that, you can, but let's go on with the rest of this video. All right, so now I have 24 volts on my R terminal here on my control board. That 24 volts is going up to the R terminal on my thermostat. Now I turn the thermostat into heating mode. I'm going to turn the power back on the unit, and what's going to happen is the 24 volts is going to go up to the thermostat. The thermostat is going to close a connection between R and W, and that 24 or 29 volts, whatever we're reading, is going to come back onto this W wire here on our terminal block on our control board. So if I were to test for 24 volts there right now, you could see I'm reading 29 volts. So that's telling me my thermostat is working properly. It's sending a signal back. But you notice the unit's not doing anything, and there's a reason why. It's because I disconnected a wire. Now you can see right here, I disconnected this black wire from the spade connector here, and this is the wire that's going up to my inducer motor, which is right here. Now the reason why I disconnected that is because when you know the sequence of operations, you can learn to read a schematic in ways that a schematic might not actually tell you. So going back to the schematic we're using today, it doesn't tell you that the inducer motor is one of the first things that are going to come on in a furnace when you're calling for heat. So when you get that 24 volt signal coming back from your thermostat on that W terminal on your control board, one of the first things should happen is your inducer motor should come on. And because it's not coming on, we're going to have to diagnose and figure out what's wrong. So knowing that our inducer motor is the first thing to come on, when we look at our schematic, all we have to do is find the inducer motor and then look at the wiring in that schematic and see where it goes. So what the schematic is showing us is that black wire from that inducer motor is coming back to our control board to a little Molex plug. So that little plug down there in the corner, that is our power for our inducer motor off of the control module. So because our inducer motor is not starting right now, this could be a couple of things. We have to test and see whether or not our control board is actually putting out 120 volts on that wire. So when I come back up, and this is the wire coming from that Molex plug on the control board, if I were to go ahead and test for voltage there on ground, I am reading 125 volts. All right, so from here to ground, I'm reading 125. So that's telling me the control board is actually sending the power out, but obviously because it's unplugged, the power's not making it to the inducer motor. So I'm going to go ahead and unplug that back in, and our inducer motor should immediately start. And as you can hear, the inducer motor is now running. Now, that was an obvious problem. I actually physically disconnected the wire, but if you actually had, this is a way you can test to see if you actually have a bad inducer motor, because the schematic is telling you there should be 115, 120, whatever the case may be, making it all the way up to this furnace inducer motor, and the motor's not running, you may actually have a bad motor. So by knowing the sequence of operations and knowing what to look for in a schematic, we knew to look for the wire that's feeding power to this inducer motor. So we were able to trace off of the control board that little Molex plug sending 115, 120, whatever it may be. I think we made 125, right? So 125 volts coming up to this wire. With it connected, we should have power to run this inducer motor so long as our control module is actually working. So if we didn't have 120 volts here and we had 24 volts on our W terminal, our thermostat was actually sending out the call for heat, we could have a bad Molex plug that's not sending power up to this inducer motor, or we could even have a bad control board. Now, once our inducer motor comes on, the next step in the sequence of operations is for this pressure switch to close. You can see there is an orange tube here connected to the casing of the inducer motor. So what happens is this inducer motor runs, it creates a slight pressure drop in this casing, and that pressure drop pulls on a diaphragm inside of our pressure switch, and that closes the switch. So what we have here is we have our control board sending 120 volts up to this inducer motor to start the motor, and then what it's doing, it's sending a low voltage 24 volt signal up to our pressure switch. So knowing that our pressure switch is the next step in the sequence, we can go back, look at our schematic, try to find that pressure switch on it, and trace out that wiring as well. So we can see here on the schematic we have the inducer draft blower pressure switch. All right, and we can see that there's two yellow wires, one feeding in, one coming out. So during the startup sequence, we should have 24 volts coming from our control module off of that Molex plug, going into our blower switch here, and then 24 volts coming out the other side, so long as this switch is closed when this inducer motor is running. So basically this pressure switch just proves that this motor is running, because we don't want to fire up the unit without this running, because what happens is the air is not going to be pulled into the unit without this running, and our flame is going to roll out, and it's going to set off our flame rollout switches, and everything's going to shut down. So I'm going to go ahead, I'm going to turn this furnace back on. I'm going to wait for the inducer motor to come on. All right, so my inducer motor came on. So what I'm going to do now is I'm going to test for voltage going to this pressure switch to see if it's going in and coming out. So when I test the wire here, you can see I'm reading my 28 volts. And to make sure the pressure switch is working, I'm going to go and test the other side of that switch, and I also have 28 volts. So I know my pressure switch is working, my inducer motor is creating a draft that's pulling in that diaphragm, closing that switch, and allowing the 24 volts to travel through. So the next step in our sequence, once our inducer motor starts and our pressure switch is proven, our hot surface igniter is going to start glowing, which will allow the gas to ignite once the gas valve opens. Now when you look inside, you're going to see two white probes that go down into the area where the gas is introduced through the jets and the flame is ignited. You can always tell which one the hot surface igniter is, because our hot surface igniter is high voltage. When we look at our schematic, that is going to be two wires, a black and a white. And as you can see here, we have two wires going to this probe. And when we go back to the schematic, we find our hot surface igniter, we find out where that wiring is going, and once again, we find it goes back to the same Molex plug that our inducer motor is plugged into. So that little Molex plug in the corner of the control board should also be sending out 120 volts to our hot surface igniter so that it will begin to glow. Now when I pull that wire up, you can see we have a connector right here that goes into our hot surface igniter. So if I ever have a problem, I go this far into the sequence and my hot surface igniter is not lighting up, what I can do to test to make sure my control board is actually sending that power to the hot surface igniter, I could disconnect this plug and I can go ahead and I can test to see if I have 120 volts going to that plug that feeds the hot surface igniter. And the reason why this is done is because if you ever do have a bad one, you can easily change it out without going through all the wiring going back to the control board. So what I'm going to do is I'm going to go ahead, I'm going to leave that unplugged. I'm going to go ahead and start the furnace back up again. We're going to have the inducer motor start, the pressure switch is going to be proven, and then we will test for power here going to our surface igniter. So right now I have one probe on ground right here. I have the other probe going into the black wire that is coming off the control board through that Molex plug. Now with these Molex plugs, I can use my regular probes because they're not as temperamental as the Molex plugs that go into the control board. So what I'm going to do now is I'm just going to wait for the time delay on the thermostat to pass. Our inducer motor will start, our pressure switch will approve, the 24 volts that the control board sends out to the pressure switch will then travel through because that switch will close. The 24 volts will go back to the control board. That tells the control board everything's okay and it can move on to the hot surface igniter. And at that point, we should start reading our voltage. Alright, so you can see now we have voltage here on our hot surface igniter. And our furnace shut down because the control board is not getting an indication that our hot surface igniter is working. So if you ever have a unit that's cycling like this and it's stopping at this point and you do have voltage here, you could end up having a bad hot surface igniter. Now obviously you could see if it's glowing or not, but if it's not glowing when it's supposed to, this is the test you can perform to see if you have any issues with the wiring, the Molex connection itself, or the control board not sending that voltage out to the hot surface igniter. So let's go ahead and let's plug this back in, shut the power off. We'll plug this back in and then we will restart this and allow it to go through its sequence all over again. Now once the hot surface igniter begins to glow, the next step is for our gas valve itself to open. So here's our gas valve. We look at the schematic, we see we have a blue and a brown wire coming to this gas valve. Now on the schematic, when we look back, we see an auxiliary switch, which is another temperature limit switch. Now when we trace this brown wire back, goes down through here, comes down through here, here's our brown wire here. All right, and it keeps going, and we could see that it goes to another temperature limit switch that's located right on our blower casing. All right, so this is sensing whether or not the blower itself is overheating. Then we got another brown wire coming out of that, and that will bring us back to our Molex plug here on the unit, the control board. All All right, so this is basically our control board sending 24 volts out to this thermal limit on our blower, which is then going up to the gas valve. Now let's go ahead and let's look at the schematic again, and when you look at it, you'll see that there's a whole bunch of wires coming out of that Molex plug, and all those wires are going to safeties. So we have a pair of yellow wires going to our pressure switch here, and that is the safety to tell us the inducer motor is running. We have wires coming off of that going to our flame rollouts. We have wires coming off of it to go to our thermal limit switch on our blower casing. We also have wires coming off of that going to our main thermal limit, which is the temperature probe that goes into the heat exchanger. So our control board on this particular schematic is sending out all these different signals on these different circuits to all these different safeties, and all those circuits have to send that voltage back to the control board again for the control board to be satisfied that everything is safe, the startup procedure can continue. And so that's basically what we're looking at, the schematic. So sometimes on schematics, you might see one wired into the other, and you can actually trace it out on the schematic. But if you don't see that, if you see something like the schematic we're working with today, basically the same thing is happening, it's just not going through one all circuit wired in series. It's basically parallel. All these different circuits are getting powered simultaneously, and unless all of them come back to the control board and check out, the control module will shut down the startup sequence. Any safeties at all when it comes to the heating sequence should be 24 volts out to it and 24 volts coming back to this Molex plug so that the control board can be satisfied. So this is basically how you can use the sequence of operations, the basic understanding of how to look at a schematic, what's high voltage, what's low voltage, where there's switches in that unit, where the safeties come into play. And by looking at the schematic, you can tell just by looking at the schematic what voltages you should expect to get at certain test points in your unit.